Hi everyone. Today we're going to be completing our notes on angles, degrees, radians, and coterminal. So I want to start just by defining what is an angle. An angle is formed by two rays that share an endpoint. So just as a reminder from geometry, a ray is like half of a line. On one end it's got an endpoint. It's finite on one end. And then on the other end, it extends infinitely in that one direction. So an angle is formed with two rays that share an endpoint where both of those rays are going in different directions. A 0-degree angle would be where they go in the same direction. Okay? In this unit, we're going to be defining angles on the coordinate plane. So on the coordinate plane, we would say that one side, one ray, lies on the positive x-axis. Okay, so one ray lies on the positive x-axis. That's usually going to be our starting ray, and then the ray that ends our measurement is going to be our terminal ray. That's where we end up. So if you've ever been to like the airport where you end up once you fly in, you land and you go through the terminal, right? The terminal is where you end up. The same idea is true for angles. The terminal ray is where your angle ends up, or where you stop measuring your angle. So it is the side of the angle where the measurement of the angle ends. Okay, so let's go ahead and sketch some angles here. We'll start with, like, say 17 degrees. So let's go ahead and draw our coordinate plane. Again, the positive x-axis is going to be our starting ray, and then our terminal ray is going to be 17 degrees rotated counterclockwise. So we would go up into quadrant 1. This would be 17 degrees. If I wanted to measure something like, say, 135 degrees, again, I would start on the positive x-axis, and then I would measure rotationally about 135 degrees, and that would land in quadrant 2. Let's do one more. We'll say 330 degrees. So again, we'll start on the positive x-axis, and I measure counterclockwise 330 degrees, and we have this angle right here. Okay? So notice that some angles are acute, some angles are obtuse, and some, they go almost all the way around the circle. Okay? Notice that each of these, all in common, they all go the counterclockwise direction, and these are all positive angles. So let's go ahead and write that. Positive angles are formed going counterclockwise. Okay, so if I were to draw this going in a circle, this would be going counterclockwise. So you might be able to guess what a negative angle might look like. If going counterclockwise is the positive direction, then it would make sense that if we go in the opposite direction, it's going to be a negative angle, and that would be true. So a negative angle negative angles are formed going clockwise. Okay, so as we go around the circle, we're going in the clockwise direction for negative angles. Okay, so let's go ahead and draw an example of a negative angle. Let's use that example earlier where we were in quadrant 2. So if I were to start again on the positive x-axis, that's going to be my starting ray, and I go in the negative direction clockwise, we'll say 225 degrees. This would measure negative 225 degrees. And we know that it's negative because we're going in the clockwise direction. Now you might notice that this is similar to the angle that we had above, which is 135 degrees. So I'm going to go ahead and write that using a different color. If I were to, again, start on the positive x-axis and then draw that terminal ray, this would measure, if I go in the positive direction, positive 135 degrees. So you might notice that we end in the same spot. Our terminal ray is the same for both of these. These share a terminal ray. And so we would call these two angles, negative 225 and 135, coterminal angles. So coterminal angles are two angles that end up in the same spot. More formally, they are angles that share a terminal ray. Okay? So two angles that share a terminal ray. They end up in the same spot. So we can say, I'll go ahead and write this out, negative 225 and positive 135 degrees are coterminal, meaning their terminal ray is in the same spot. Okay? So if we wanted to find this, you might notice the relationship between negative 225 and 135. Notice that if we were to combine these two, they form one full circle, right? So if I wanted to go from negative 225 to 135 algebraically, without having to draw a picture, I could find a coterminal angle by adding one full rotation. So going in the positive direction, counterclockwise, one full rotation, and I'm going to land in the same spot, 135. Likewise, if I wanted to go from 135 to negative 225, I would start at 135 and subtract one full rotation. So going in the negative direction, clockwise, one full rotation. And we know that in degrees, one full rotation is 360 degrees. So I'm going to go ahead and write that. To find a coterminal angle, you take your angle theta. So theta is just the capital Greek letter, represents an angle. And we can add or subtract 360 degrees. And we're going to say 360k, where k is an integer. Okay? So an integer, as a reminder, those are your counting numbers, 1, 2, 3, 4, 5. It's your negative counting numbers, negative 1, negative 2, negative 3, negative 4, negative 5, and then also 0. Okay? We're going to see one more example of finding coterminal angles, but now in a different form, and that's going to be radians. I'm going to give you the definition now, and then we'll talk about it in just a moment. If you have your angle, so theta in radians, you can add or subtract to pi k, again, where k is an integer. Okay? But in summary, coterminal angles, they can be found by adding or subtracting one full revolution around the circle. Okay? All right, so there's one more angle that I want to talk about, one special type of angle, and then we'll talk about radians. And that special type of angle is called a quadrantal. So if you look back at the earlier examples, we had angles in quadrant 1, quadrant 2. You could have one in 3, but we didn't have one. And then also in quadrant 4. But what if the terminal ray is exactly on the axis, right? So the positive or negative x or y axes. These are in none of the quadrants because it lies exactly in the middle of the quadrants. So these angles are special types of angles called quadrantals. Okay, so we'll go ahead and define that. Quadrantals are angles whose terminal ray lies on an axis. Okay, so in degrees, our quadrantals, if we start at the positive x-axis, that's going to be 0 degrees. I know that one full circle is 360 degrees, so that's also going to be here. By the way, 0 and 360 are coterminal. The negative x-axis is going to be halfway, or 180 degrees. The positive y-axis is going to be halfway in between 0 and 180, or 90 degrees. And then the negative y-axis is going to be halfway in between 180 and 360, or 270 degrees. All right? Okay, so now I want to talk about radians. Radians are just another way to measure angles. Let's go ahead and define them. Radians, another way to measure angles. And radians are nice. They come in handy when we're talking about an angle with respect to a circle's radius. Or, well, we'll use it in terms of a circle, the unit circle. Um, but it has to do with the radius of a circle and how many radii would stretch across an arc length of the circle. So let's try to visualize this. If I were to draw the coordinate plane and some circle centered at the origin, some circle with radius r, and let me draw that a little bit better. Some circle with radius r. Well, then I'm going to go ahead and use a different color. If I were to say that here's my center, and we have some distance r, right, is our radius. If I were to take that radius and kind of bend it around the curve of the circle, I would get that one radius gets right about here, right? And if I were to take another radius and bend it around the circle, it would probably be like right here. And then we'll take one more radius and bend it around the circle. It would probably be like right here. Okay? So these are 3 radii. The additional amount of the radius, and this isn't quite drawn to scale, is about 0.14 radii. Okay? If I were to continue, so starting back at 3 radii and then drawing one more full radius, that would be a radius. Another radius would be like maybe right here. And then one more radius would be like right here. There would be an additional bit left over right here, and that's approximately 0.28 radii. So you might notice that all in all, if you count all the radii that it takes to stretch around the circumference of a circle, you have 1, 2, 3, 4, 5, 6, and then a 0.28. This is exactly 2 pi radians. And that's where we get the formula for the circumference is 2 pi times the radius, right? But like I said, radians are not they are not distances around the circle. That's arc length. They are another way to measure angles. So let's take a look back at just one radius around that arc. We have this angle formed right here. That angle, theta, is going to be 1 radian. So that measures the angle that is needed for 1 radius stretched across the arc length. Okay? So you might also notice that in one full circle, there are 2 pi radians in angles, right? And then a half circle would be just pi radians. Okay? So actually, let's go ahead and draw the coordinate plane. We'll label our quadrantals. The positive x-axis is 0 radians. We already said that one full circle is 2 pi radians. So then a half circle is pi radians. The positive y-axis, that's going to be halfway between 0 and pi, or exactly pi halves radians. And then our negative y-axis, that's going to be exactly in between pi and 2 pi. That's going to be 3 pi halves radians, or 1.5 pi. Okay, so these are our quadrantals in radians. If I wanted to start sketching some of these angles, like let's do pi sixth, I know that pi sixth is going to be in quadrant 1. So that's that angle right there. Pi sixth is in quadrant 1 because it's greater than 0 radians, but it's less than pi halves radians. I know 1/6 times pi is less than 1/2 times pi, right? Likewise, if I wanted to graph, say, 2 pi thirds, I know that's going to be in quadrant 2. So 2 pi thirds, we're going to go ahead and label up here. And I know that's going to be in quadrant 2 because it's greater than pi halves, but less than pi. Or in other words, 2 thirds times pi is greater than 1/2 times pi, but less than 1 times pi, or 3 pi thirds. Okay? We'll do like 5 pi fourths is going to be in quadrant 3. 5 pi fourths. That's like 5/4 pi. That's exactly in the middle of pi and 3 pi halves. As a reminder, 3 pi halves is about 6 pi fourths. Not about it, it's exactly 6 pi fourths. And then let's do one more, 5 pi thirds. I know 5 pi thirds is in quadrant 4. And that's because 5 thirds times pi is greater than 3 halves times pi, but less than 2 pi. Okay? All right, so you may have noticed that if radians is another way to measure angles, well, then there must be some unit conversion between degrees and radians, and you would be absolutely correct. So let's go ahead and convert. This is the last thing we'll talk about today. Converting between degrees and radians. Okay? So converting between degrees and radians. Well, we know that there are 360 degrees in a circle, right? We also know that there are 2 pi radians in a circle. So our unit conversion, we know that these represent the same thing. It's one full rotation around the circle. Okay? So to convert between the two, we can use these pretty interchangeably. We can say that the ratio of degrees and radians is simply 360 degrees per 2 pi radians. Or, in other words, that's 180 degrees per pi radians. Okay, so this is going to be our unit conversion right here. So if I wanted to go from degrees to radians, then I would start with my angle theta in degrees, and I would multiply by pi over 180 degrees. Okay, so pi radians times over 180 degrees. And the reason why is because I want to cancel out those degrees and be left with my units, radians, my angle in radians. And so that's going to give me my theta, my angle in radians. Likewise, if I wanted to go from radians to degrees, then I would take my angle theta in radians, and I would multiply it by my unit conversion, 180 degrees per pi units, pi radians. And that's going to give me my theta in degrees. Okay? So we talked about a lot today. We talked about angles. We talked about positive and negative angles. We talked about terminal rays and coterminal angles. And we talked about quadrantals, degrees and radians. Radians are another way to measure angles. And then also converting degrees to radians and radians to degrees. We're going to get a lot of practice on this, so we'll see you tomorrow. Have a great day, everybody. Goodbye.